So the next examples are going to be cases where you cannot solve them by hand. Right? It's impossible. You have to solve them graphically. And the reason why, if you look at the first equation here, is you've got an x term here, and then you've got x in your exponential term. And if you try to manipulate it and change it out, it's always going to be buried. So you're going to always have an x term on the outside, an x term inside an e, or an x term inside a logarithm. All right, there's two ways to solve it graphically. All right, you can either set it equal to 0, find its zeros, or graph both sides and find where they intersect. All right, so if I do the 0 case, so if I move the 2 over, I get 12x minus 2 plus e to the x equals 0. I graph this equation and find its 0. And that's one way to solve it. And so if I graph, standard window should work. And so again, in your calculator in y1, you'd graph 12x minus 2 plus e raised to the x. Standard window, and actually it's pretty looking like it's a pretty straight line. Right, it kind of comes up like this, and there's that equation, and we want to find its 0. And so to find the 0, you would hit second trace, second one down, 0, and then it'll ask you left of it, right of it, 0, and then you find it, and it'll give you your approximate answer, which is 0.077. Right, that's one way to solve it graphically. So this is if we graph and find a 0. There is an alternative method which the book talks about in this section and actually in some earlier sections, is you can use the intersect. So what you could do, so an alternative graphical method. So there's one, that gives me one answer. I can get the same answer in different ways. You could graph both sides and find the intersect. Alright, so y1 would equal to 12x plus e to the x. y2 in your calculator would equal 2. And so you'd graph two things. So the first graph would look similar to the one that is listed there. It is still kind of this equation. That would be the 12x plus e to the x. And then your calculator would graph a straight line. That would be the y equals 2. And then we'd find where they intersect. And find that x value and it would come up to the same thing. So again, in the calculator, you'd go second trace. You'd go down a little bit and find the intersect. I think it's 5. And then it'd ask you first curve, second curve, and guess, and it will give you the same answer. So you can solve this graphically, and there's two ways to solve it graphically. Set it equal to 0, graph it, find it 0, or graph both sides of the equal sign and find where they intersect, and both of those are fine. Alright, you can use either method. Alright, so I'm going to do a second example. So again, same thing, I'm going to show you both methods. You could do the 0 case or the graph both sides case. So again, it's just up to you however you want to solve it. So if I'm going to do the first case, I'm going to have to move the 2 over and solve for the 0. Alright, so if I do the 0 case. So set it equal to 0 first. So I'll set it equal to 0. So move the 2 over. So x squared minus x times the natural log of x minus 2 equals 0. Graph this side and find it 0. So if you do that, standard window I believe should work just fine. Alright, so it comes up like that. That's the graph x squared minus x times natural log of x minus 2. We're looking for the 0. Alright, so you hit second trace, 0. Left side, right side, guess. And so when you do that, you go to the left of that point, the right of that point, and you hit guess. It should come out 1.0706 would be the answer. Alright, that's using the 0 method. Or, like I said, there's the other method. You could graph both sides. So graph both sides and find the intersect to solve. Alright, so y1 would be the x squared minus x times the natural log of x. y2 would be the 2. And so you would get a graph. The first graph looks very similar. It's just been shifted up a little bit. There's the x squared minus x times natural log of x. And then you get your horizontal line, y equals 2. And then you find where they intersect. Right? We want to find the x value. And so you use the intersect. It gives you the same thing. So you pick whichever, both graphical methods work. So if you like the zero method, use the zero method. If you like the graph both and find where they intersect method, use the intersect method. Both of the methods are perfectly fine. And like I said, all of the applications that we solved in the earlier, you could go back and solve them graphically. The downside to the graphical method is you cannot find the exact answer, but we don't always need the exact answer. Alright, so you can always use these methods to solve. But both of these are examples of cases where you had to solve graphically. And the reason why is because you had x term buried inside a log or an exponential and outside of the log and exponential. Whenever that's the case, you can't solve them by hand. You have to solve them graphically. Alright, so we're almost done. The last thing is just to get through applications, and so I'll do the applications in my next video.